All right, hello again. Here we go. This is video number 2. So today we're going to talk about factors, prime factors, and factor trees. We'll talk a little bit about prime numbers. Might go off on a tangent or two. You never know. Things prime numbers are going to come back again and again. So I'm not going to put too much in this video because we'll have a lot more going forward. But here we go. Let's start by thinking just about factors. Now, a few of these things on this page your eyes might be popping out of your head, and I don't want you to worry too much about it. I just want you to understand and maybe reflect on this in later years that a factor just means numbers or letters, variables, whatever, that multiply together to achieve a product. So if you look below, 6 is a product. 2 times 3, those are the factors. So 2 times 3 equals 6. Factor, factor, product. Those are the ones we're going to look at in this section, but I wanted to show you what else is also considered factors because it'll help you later. This statement here, 2x. 2x means 2 times x, which means you have a factor of 2 and a factor of x. So a variable can be a factor as well. In fact, variables will be factors quite regularly as we move forward. And then you can see here, right, even entire expressions. So in this case, the 2 is outside the bracket. So what that means is 2 times this whole thing here. And since it's multiplication, it means 2 is a factor. And yeah, this whole expression x plus 3 is a factor. I'm going to do a video on substitution and how you can simplify expressions to make them easier to deal with. You'll see that probably in a much later video, maybe in the grade 10 or 11 section, but substitution is very handy. But for this video, factor, factor, and when you multiply them together, you get this product. Don't stress yourself out too much about that. We will talk about it in future videos in this grade. It's called the distributive method, or I like to call it water bombing. But again, don't get too boggled down. This is where we're going to live in the next few minutes here, okay? Just basic whole numbers times each other. Factor, factor, and the answer is the product. So let's just look at that. If someone says, what are the factors of 36? And I'm going to specifically show you how I list these because there's an interesting thing here. Well, it's any two numbers that multiply to 36. So, well, obviously 1 and 36. And then 2 and 18. And then 3 and 12. And then 4 and 9. And then 6 and 6. So one thing you might notice, as the left side increases in size, the right side decreases in size. So essentially what is happening is we're getting closer and closer to a midpoint. And 36 has a midpoint, which you'll see in our square and square root video. If you have a midpoint and the number's exactly the same, here comes a bit of a spoiler, you have a perfect square. And the square root is whatever number is an identical factor. Again, that'll be the focus of a couple videos from now, but just a little preview for you. But all of these combinations, 1 times 36 is 36, 2 times 18 is 36, 3 times 12 is 36, 4 times 9 is 36. All of them work. And as you get closer and closer to the midpoint, which in this case is 6, you know you've got all the factors. That's the other thing I wanted to show you with this here, is that midpoint, and I'll touch more about this when we get to squares and square roots, but that midpoint is super important because when you get to the midpoint, like, I know, here's what you need to see. I have a 6 here, right? And I have a 6 here. So as I was increasing these numbers, I'm increasing potential factors. The only number missing from this list is the number 5. And 36 is not divisible by 5. And then after 6, you get to 7. But 7 would not appear on the left because you have a 6 on the right. 7 would be in here if it was a factor, right? You can fill in all the numbers that are missing in between all of the factors. And the thing is if you don't have one on the left, it won't have a partner on the right. So a lot of times what I see kids doing when they have to find factors of numbers is they just start dividing things by everything. They'll grab their calculator and they'll just go, oh, 36 divided by 1, by 2, by 3, by 4. And then they'll just keep going. They'll go 8, 9, 10. They'll just try everything. Be strategic. If you look at just this breakdown, once you get to 6, you're done. If you took your calculator and were like, oh, 36 divided by 1, 36 divided by 2, 36 divided by 3. I mean, yeah, in this case, 36 is a good number. These are all going to work. 36 divided by 5, that's the first time you'll get a no. Then 36 divided by 6, you get 6. Now, you should never have to try 36 divided by 7, because if you did, it would be one of these numbers, because 7's over here. Right? So when you're trying to find factors, you only have to try the one side of the square root. So if I really wanted to get all the factors of 36, I would only ever have to divide it by the factors below 6. And when we start talking about primes again in the next video, I'll show you how to determine if a number is actually prime. It's going to be great. But this is a nice little addition to factoring. It really helps with that deeper understanding. So let's get the factors of 18. Well, 1 and 18. Well, 18's even, so 2 and 9. Okay, well, 18 is also divisible by 3, so 3 and 6. And you can see here, I'm already at 6, and here I'm at 3. So if there were any other numbers, it would have to be 4 or 5, because I have a 6 on the right. And 18 is not divisible by 4, and it's not divisible by 5. So you know you're done. Those are the factors of 18, because there's no room in between 3, 4, 5, 6 that you haven't already tried. So those are your lists of factors. And you have 3 different sets of factors here, okay? You would have this, you would have this, and you would have this. 3 different choices. This is going to come in really handy. Grade 10 video, polynomials, factoring, basic quadratics. So look for that in the grade 10 video when you get there, if you're ready for it. So let's just talk now about prime numbers. So prime numbers are crazy, very helpful. There's an infinite number of prime numbers, which means they go on forever. And we don't know what the next largest prime number is. I don't have it off the top of my head, but the prime number that they've found recently, and by recently I'd say probably in the last 5 years, is absolutely gigantic. And you couldn't even comprehend how big the number is. Like, it's like millions of digits long. It would fill an entire wall or an entire room. Too much paper. Like, computers working together have to figure them out, because the numbers are so huge. It's mind-boggling, and it's not easy to find. They don't know what the next one is, but they know it exists. But it's just, prime numbers are wild. I put a little list on the bottom, but important definition of a prime number. Because the definition precludes one number from the list below that you might be thinking about. And it's a prime number is a number with only two unique factors, 1 and itself. So what does that preclude? Well, you can see in the list below, a lot of people think 1's a prime number. 1 is not a prime number. And 1 is 1 times 1, but that is not 2 unique factors. So for that reason, 1 is disqualified from this list of primes. All the rest of these in this list are just 3 times 1, 5 times 1, 7 times 1. It's the only thing you can do. Now, 2 times 1. 2 is a really special one, because 2 is the only even prime number. Why? Well, because every single other even number is divisible by 2. And you can see here the list, the numbers are pretty crammed together. But as you get higher and higher and higher, the numbers get more and more spaced out, because every single multiple of the number that came before it is now no longer a prime because it has a factor before it. So you can see like every multiple of 2, all the even numbers are gone. Every multiple of 3, 6, 9. Well, 6 is already gone because it's even, but 9's gone because it's a multiple of 3. And then when you get to 5, 15's gone, 20's gone, 25 is gone. So the list gets tapered out further and further and further, but it starts pretty crammed up. You're going to see in the next video that it's super helpful when you start trying to divide numbers. These are my go-to 4 every time, and I'll tell you why in just a few minutes. And by a few minutes, I mean right now. So prime numbers, if you're not prime, you are what is called composite. So 18 is a composite number because it's not a prime number. Now, what a composite number is, and what every single composite number can be, is written as what is called a product of primes. We call this prime number factorization. So we factor a number down into a product of primes. So I'm going to be more clear on this in an example to follow, but I can just tell you now, 18 is 2 times 3 times 3. 2 times 3 times 3 is 18. So this is what we call the prime number factorization of 18. Knowing what a number is made up of is crazy helpful. So let's see this in play with what we call factor trees. Now, right before we jump into that, just a few little notes. Primes are incredibly helpful. They're the smallest factors you can break a number down to. And when things get to their smallest pieces, we can understand them better. And just a little nerd out here for you, consider science, studying science and chemistry without atoms. Atoms, the smallest building blocks of elements, and I'm blanking on my science vocabulary right now, but atoms are small. I mean, there's smaller parts within the atom, electrons, quarks inside the electrons, but knowing about atoms helped us learn so much. And then with medicine, if we didn't understand about DNA, or we weren't able to map the human genome, like we start to learn more and more about ourselves because we can break ourselves down to the smallest possible components that make us up. Prime factors are exactly the same. And factors, prime factors, they're going to come in handy in fractions. They're going to come in handy in lowest common multiple, greatest common factor. You're going to see them over and over again. So be ready. So on that note, we're going to talk about factor trees. So breaking a prime number, or a composite number here, into its product of primes. And we do that by doing what is called a factor tree. So this is where you're going to see that division from the previous video come into play. We're going to do short division when we have to, and then also identifying what a number is divisible by. So first one here, 210. I'm going to look at that, and right away I see a 0. So I'm like, well, I know I can divide that by 10. And you might be saying, whoa, Herlaar, you can divide it by 2, you can divide it by 5. Yeah, sure. But start with the highest possible factor because it just makes the number smaller faster. And any number divisible by 10, you just divide it by 10 and you chunk the 0 off. So it's 10 times 21. Now, this is what we call, I'll underline them, but then I'll get rid of it. That's the end of a branch. That's the end of a branch. That's what I mean by branches. Okay, now, when we're doing prime number factorization, we only care about factors at the ends of branches. Because how this reads is 10 times 21 is 210. But 10 is just 2 times 5. So now the 10 is obsolete because the 2 and the 5 is the 10. So now you have 2 times 5 times 21. That's the same as 10 times 21, but now I have a prime and a prime, which is what I want. Primes at the ends of my branches. 21, well, 2 plus 1 is 3, so I can divide it by 3, is 3 times 7. So now the 21 is obsolete because the 21 is represented by the 3 and the 7. So you can see at the ends of all my branches now, I have only prime factors. And remember that multiplication, 2 times 3 is 6, 3 times 2 is 6. Order doesn't matter. So I like to write it in increasing order. So the list of my primes is going to be 2 times 3 times 5 times 7. That is the prime number representation, the prime number factorization of the number 210. That is the number 210. It's just written as a product of primes. That is the number 210. But we know what it's made up of. Super handy. You'll see it later. So that's how factor trees work. So let's do another one, 84. Well, I look at 84 and it's even, so I'm just going to divide it by 2. Now you might be like, whoa, 84, back 2 digits, divisible by 4. We can divide it by 4. And yes, you're not wrong. So look at you. You're already jumping in your divisibility rules. But I'm going to go 2 here. 2 goes into 8 4 times, no remainder. 2 goes into 4 twice, no remainder. 42 I'll divide by 2 and I get 21. And then here we go, 21 again, 3 times 7. So look at the ends of your branches. 2, 2, 3, 7, all prime factors. So that means that 84 is equal to 2 times 2 times 3 times 7. That is the prime number factorization of 84. Again, going to be really helpful when we need it. Let's do another. 24. Well, 24 is divisible by, and you can do these, watch this, actually, I'm going to do this twice. 24, well, I know 24 is 2 times 12. And I know 12 is 2 times 6. And I know 6 is 2 times 3. Okay, well, you might be saying, yeah, but I was going to start by going, well, 4 times 6. Well, yeah, and then 2 times 2, and then 2 times 3. And then someone else might be saying, well, I was going to go 3 times 8. Yeah, and then 2 times 4, and then 2 times 2. And if you look at the ends of all your branches, 2, 2, 2, 3, 2, 2, 2, 3, 2, 2, 2, 3. It doesn't matter how you get there as long as you don't screw it up. So 2 times 2 times 2 times 3 is the prime number factorization of 24. 57. 57 is my favorite number because I often think, well, it's not my favorite number, 5 is, but I often think, that's got to be prime. It just looks like it'd be a prime number. But then you just got to think. Divisibility rules. Is it divisible by 2? No, it's not even. Is it divisible by 3? Well, what's 5 plus 7? 12. 12 is divisible by 3. So that means I can divide this number by 3. 3 goes into 5 once with 2 remainders. So here's that short division, right? 3 goes into 27 9 times. So 19 is prime, 3 is prime. So 57 is 3 times 19. It's still a prime number factorization. Don't get upset with 19 because it's a bit bigger. It's still a prime. So we're good. 2 more. So 1170. Well, ends in a 0. Let's start there. 10 times 117. Well, 10 is 2 times 5. Now, you might be looking at number 117 thinking that's got to be prime. It's got a 7 on it. And sometimes brain logic like that, it seems like it should be right, but you actually got to look a bit deeper. Just because it ends in a 7 means nothing, okay? 7 plus 1 plus 1 is 9. Divisible by 3. 3 goes into 11 3 times with 2 remainder. 3 goes into 27 9 times. Now you might be looking at 39 and saying, well, that's definitely prime. Look at that. Well, what's 9 plus 3? 12. So I can divide it by 3. 3 goes into 3 goes into 3 once, 3 goes into 9 3 times. So now prime, 1,170 is 2 times 3 times 3 times 5 times 13. That is my prime number factorization. Yes, that number is 1,170. But now I know what it's made up of. Good? Great. Last one, 336. Well, I could divide it by 2. I could divide it by 3. I could divide it by 4. World's your oyster. If you can divide it by 2 and 3, you can divide it by 6. So hey, let's do 6. 6 goes into 33 5 times with 3 remainder. 6 goes into 36 6 times. Well, 6 is just 2 times 3. 56 is, let's go 2 times 28. You could have gone 7 times 8. Do what you want. 28 is 4 times 7. 4 is 2 times 2. Prime, 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 prime. So what's the factorization, prime factorization of 336? It's 2 times 2 times 2 times 2 times 3 times 7. Boom. So right now you're thinking, yeah, this is pointless, who cares? But you're going to see when we get into fractions, when we get into lowest common multiple, this is going to be incredibly handy, super helpful. And it really gets you into when you can cancel factors, which is a recurring theme all the way up to calculus. So understand factors, understand breaking things down into factors, and then particularly prime factors. That's it for this video. Again, if you liked it and it worked for you, please subscribe. You'll get notifications for new videos. Throw some comments in if you want to see something in particular or if you're confused about anything. And coming next, I think I'm going to be putting together a lowest common multiple and a bit more on primes. If you want to see a video for grade 10 material, 11 material, or 12 material, throw it in the comment section, and I'm happy to get that out sooner than later. Yeah. Thanks so much, and keep it up. You're doing great.